Hi, I am Dr. Zeinali, Assistant Professor of Digital Manufacturing in the School of Mechanical and Materials Engineering at University College Dublin. I led several industrial and academic research projects in the field of data analytics and machine learning. Imagine your team needs to provide a data analytics solution to meet a business need, and you intend to engage in or manage this project. The questions that arises are how to develop an appropriate data analytics solution, and what predictive model is the best choice of this solution. The aim of this course is to answer these questions and provide a unique opportunity to gain insights into the fundamental concepts, techniques, and applications of data analytics in an industrial environment. An important objective of this course is to explain key steps involved in a predictive data analytics project. The course doesn't involve coding, however, easy-to-use choices are available for practitioners who are interested. This course is designed for professional learners to acquire fundamental skills necessary to effectively engage in and manage data analytics projects. There will be a 2-hour live session each week, and a pre-recorded video will be made available for those who are unable to attend. The course includes a series of activities such as article reviews designed to help you identify a solution for a business or industry challenge of your choice. These activities are intended to support your assignments. 3 assignments are designed for you. The first assignment is developing a data analytics solution for your chosen business or industry challenge. The second assignment requires you to review a peer-reviewed article related to your challenge. And the final assignment is to prepare a project report or presentation detailing the solution you propose in the first assignment. On successful completion of this course, you will be able to provide data analytics solutions to address industry data-related challenges, select the most appropriate data analytics approaches tailored to the available dataset and project challenge, analyze real-time and historical data, define main steps needed in the data preprocessing, demonstrate an in-depth understanding of predictive data analytics lifecycle and stages, demonstrate an understanding of different data analytics approaches. The term data means stored information, and according to Merriam-Webster, analytics is defined as the method of logical analysis. So with these definitions in mind, how can we define data analytics? Data analytics is a pivotal step in the journey from data to decision. It provides insight from data that can enable us to make more informed decisions. This can add significant value to your organization. Data analytics can be divided into 4 distinct types based on the insight they provide: descriptive, diagnostic, predictive, and prescriptive data analytics. Descriptive data analytics summarizes historical data and identifies relationships within that data. If you aim to gain better understanding of what happened in your process, descriptive data analytics can be an excellent choice. Diagnostic data analytics investigates why a particular event, for example a relationship, happened. Predictive data analytics make predictions about the future using historical data. And prescriptive data analytics recommends optimal actions to achieve desired outcomes for your business. For example, optimize maintenance scheduling. In this course, our focus is on predictive data analytics and the projects associated with it. Like any other project, predictive data analytics projects have a life cycle. So what does the life cycle of a predictive data analytics project look like? It begins with the identification of a business need and ends with deployment of a solution to address that need. These projects can be managed using a standard process to increase the success rate of the project. The Cross-Industry Standard Process for Data Mining, or CRISP-DM, is one such standard process that has been widely used in these kind of projects. CRISP-DM consists of 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. In this course, we will discuss this standard process in depth, and you will apply it to your chosen industry challenge. In the modeling phase of the CRISP-DM, you can use various algorithms such as machine learning to develop your prediction model using the pre-processed dataset. Now the question arises, What is the most appropriate algorithm for your industry challenge? We will discuss this in detail throughout the course. Let's start with a prediction model example to understand why we need machine learning. This example is related to a production line in the automotive industry. Production time is a critical parameter in the automotive industry. Current historical data shows that the number of features of a car is the only parameter that affects the car's production time. A simple prediction model for this historical data predicts that if the number of features in a car is less than 5, then the production time is short. If the number of features is between 5 and 10, then the production time is medium. Otherwise, the production time is long. This model accurately predicts production time based on the current historical data. Let's consider more parameters in the data, such as production line efficiency and availability of parts. This makes the system more complex, and therefore it will not be an easy task to develop a prediction model. This is where machine learning, especially supervised machine learning, can help by automating the learning process. Machine learning algorithms can be classified into 4 main categories. The first category, supervised learning, uses historical labeled data, which includes descriptive features as inputs and target features, the labels, as outputs, to learn the relationship between inputs and outputs. The second category, semi-supervised learning, is similar to the previous category, but uses a combination of labeled and unlabeled data. If you have a huge amount of unlabeled data and would like to identify hidden patterns, then unsupervised learning, the third category, is a good choice for you. The fourth category is reinforcement learning. In this type of machine learning, an agent learns how to interact or behave in an environment by taking a certain action and receiving feedback, which can be a punishment or reward. A good example is a machine learning algorithm that learns chess by playing it multiple times. This course will focus on supervised learning. If this course has sparked your interest, please apply for it.